Hello everyone, welcome back. Today we're going to be talking about proving that two triangles are similar. And when we do that, we're going to be using these similarity theorems here. This is how they read. This first one here, SSS squiggly line, well that squiggly line means similarity. So we're going to read this as side, side, side similarity. Here we have angle, angle similarity, so that's angle, angle similarity, or AA, right? And here we have SAS squiggly line, so that's side, angle, side, similarity. So these are just the theorems. Right now, we're going to be going into depth on how to do side, side, side similarity and angle, angle similarity. And I'm going to leave side, angle, side as your extension. Hopefully, you guys can piece together how to do it once we go over these two. So let's get right into it. So here we have triangle CAT and triangle DOG. And it's asking, is triangle cat similar to triangle dog? Well, if we look at what's given to us, we have all three sides for triangle cat and we have all three sides for triangle dog. If we're given all the sides for both triangles, then we know we can use side, side, side similarity. Right? So that should be an automatic. If you see all the sides, then you know, hey, I should be able to use side, side, side similarity. Now the question is, how do we use it? Well, to use it, what you do is you're going to create ratios between all these sides. And the way I like to do it when it's clear, I like to create ratios of big over small. So I'm going to take this big side and put it over the corresponding small side. So that 10 corresponds with that 2.5. So 10 divided by 2.5. And if I plug that into a calculator, I'm going to get 4. Another corresponding side would be 6 with this 1.5. So if I take 6 and divide it by the 1.5, if I take that and plug that into a calculator, what I'm going to be getting is 4. Again, which is like, okay, cool. Look, we have two ratios, and these two ratios are giving us the same answer. Okay, let's see if the last one gives it to us. 8 and 2. Well, if we take 8 divided by 2, well, that one we do know is 4 without, you don't need to plug that one in a calculator. So what we're going to do here is these three right here are our reasons as to why these triangles are similar. So these three are our reasons that are going to point down to our conclusion. Our conclusion here is just what we wanted to prove from the beginning. What we're being asked to prove. We were being asked to prove, is triangle CAT similar to triangle DOG? And the answer is yes. We're going to put a little similar sign here. If it wasn't similar, we put a slash through it or something. We would say not similar. But they're similar, so we just put the little squiggly line. Remember, this little squiggly line here means similar. And down here, for good practice, I want you guys to write reason and then put your reason. So my reason here is SSS similarity. So that's how you do side, side, side similarity. When we do angle, angle similarity, in this case, what you're looking for is not all three sides, but, what you might guess is we're looking for two angles. We're looking for two corresponding angles that are the same. This time we're not going to be creating ratios. This time we're looking for two angles that are in corresponding spots that are congruent. Congruent means the same, and this is the symbol for congruency. Right, it's an equal sign with a squiggle on top. So here I can look at this angle here, O, is the same as this angle A. The way, right, if you guys remember our angle relationships that we were looking at last week, you remember these symbols, so you know that those two triangles are similar, or those two angles are similar, or actually, congruent. So we have angle O is congruent to angle A. And over here, with these two angles here, we have angle H is congruent, well, it's not a congruent symbol, is congruent to angle J. Now, just like side-side-side similarity, these are reasons to our conclusion. These are the, like my arguments as to why my conclusion is true. So my conclusion now, I can say that a triangle HOT is similar, I was about to say congruent, it's similar to triangle JAM. Again, our reason, right, overall, the theorem that we're using to prove this is angle-angle similarity. Now, I want you guys to try this next one on your own. Right, it's going to be one of the two we've gone over so far. It's either going to be side-side-side similarity or angle-angle similarity. And there's a hint here. I want you to take a good look at this hint and prove that these two triangles are similar. Alright, hopefully you got a good look at it. And now you have tried it and you have an answer, hopefully. Well, what we're looking at here is we have angle-angle similarity because of these vertical angles. These vertical angles pop up, right? Remember we were looking at angle relationships last week? So these two here are vertical angles, and we can show now, because we have two pairs of congruent corresponding angles. Angle B corresponds to angle D, and they are congruent based off the markings. And angle ACB is congruent to angle DCE. This one, our reason for that one is for vertical angles. And just like before, right, those are our reasons, and now we write our conclusion, which would be triangle ABC is similar to triangle EDC. And what's our reason? Our reason is AA similarity. So hopefully you guys got that. Hopefully you guys got this. If you didn't, come talk to me. We'll see, maybe we got some confusion somewhere. If you didn't get it, then if you did get it, then great. If you didn't get it, we can definitely go over this and make sure that you understand this in the future. For our extension here, I want you guys to be able to do side angle side, but I think with what we've gone over already with side 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 and angle angle, you guys can kind of piece together how side angle side is going to work together, or how it's going to work out. Right, it's going to be the same structure. We're going to create our little flow chart here. I want you guys to determine whether we need 3 or 2 bubbles, right? Because side 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 needed 3 bubbles and angle angle only needed 2. I want you guys to decide how many reasons we need to get to our conclusion. So hopefully you guys get that. I'm going to want to see this extension, and I'm going to want to see the try it on your own. I'm going to want to see both of those tomorrow morning when I'm walking around the room checking your guys' homework. This will be your homework that's due tomorrow. I'll be walking around the room during the warm-up to see this. And that's how you get credit for this.